In this screencast, I will show you how to write equations for given parabolas and how to graph quadratic functions of the form f of x is equal to ax squared plus c by using the graphic organizer that we used in the previous lesson. In the first slide, we're given two parabolas. The gray graph is the original parent graph for f of x is equal to x squared. Now the black parabola is for g of x, and we're asked to find the value of k that represents the new location of the vertex of the parabola in this figure. So since we know that this parabola is a vertical translation of the gray one, by how many units up? So that's going to be 1 unit up. So that means the vertex will now be transferred from 0, 0 to 0, 1. So let's replace k here by 1. And that will be the new function for this parabola. In the second example, this is the original one. And it now moved how many units downward? That's 1, 2, 3, 4, 5, 6 downward. So the original vertex 0, 0 will now move to 0, negative 6. So let's replace this k here and the plus sign with negative 6. So that's how you write equations after transforming parabolas vertically either upward or downward. Now in this slide, we are going to look at how we can use a table of values to graph a given function. Let's say g of x is equal to x squared plus 4. At this point, you should be familiar with the x values that we normally use in our table. So from negative 2 to positive 2. Although last time I mentioned that you can also use from negative 1 to positive 1 only. Okay, so to get the y values, we use the parent function, which is x squared. So x squared is you multiply the number by itself. So negative 2 times negative 2 is 4. Negative 1 squared is 1. 0 squared is 0. 1 squared is 1. And then 2 squared is 4. Okay, so this is our original x value and our original y value for the parent function. However, in this new function, we're adding plus 4. So that means we're adding 4 to the original y value because the original y value was x squared and then we add 4. So let's show those values in this column. It means add 4 to every single one. So 4 plus 4 is 8, 1 plus 4 is 5, 0 plus 4 is 4, 1 plus 4 is 5, and then 4 plus 4 is 8. Alright. Now, let's look at the transformation. Since we added 4 to our original y value, then we say the graph of g of x is a vertical translation. How many units? It's 4 units up of the graph of f of x is equal to x squared. So let me copy this x squared down over here. Let's see here. There you go. Right. Now let's look at the vertex. So even without seeing the actual graph, we can get this information from the table of values. So the vertex is at 0, 4. Now, is it a minimum or a maximum? Since we know that our parabola is going upward, because the sign of a here is positive, so it's concave up. If the parabola is concave up, then this vertex here will be the minimum, because it's the lowest point. Now, the axis of symmetry is x is equal to, and then you use the x value over your vertex, which is 0. And then the domain, we said it's always all real numbers. Now the range is, we say y is greater than or equal to. And and then we use the y value of the vertex. So how do I know that it's greater than? I know that it's greater than or equal to because the parabola is opening upward. So it has a minimum point at its vertex. So all the values above the vertex are greater than 4. Now, where is it increasing or where is it decreasing? So we use the variable x for this one. It always follows the same sign as the range, so it's greater than. And then since it starts with x, we use the x value of the vertex, which is 0, while the other direction, which is x is less than 0, is where the graph is decreasing. In the next example, we're going to graph g of x is equal to negative 2x squared minus 1. So again, it helps if you write down your original table of values for the parent graph. So we said this was 4, 1, 0, 1, and then 4. Okay, so if we follow the order of operations, we multiply first before we subtract. So that means our original values, which were x squared, will now be multiplied negative 2. So that means if we multiply 4 by negative 2, we get negative 8. 1 times negative 2 is negative 2. 0 times negative 2 is 0. 1 times negative 2 is negative 2. And then 4 times negative 2 is negative 8. And then after that, we have a newer y, and now we have to apply the negative 1 or subtract 1 from the original values, which were eventually multiplied by negative 2. So after multiplying by negative 2, we subtract 1. So we have a column for newer y. So we subtract 1 from all of these values. So negative 8 minus 1 will be negative 9. Negative 2 minus 1 is negative 3. 0 minus 1 is negative 1. Negative 2 minus 1 is negative 3. And negative 8 minus 1 is negative 9. So going back, these were the parent functions, and then we applied the product here, which is negative 2. So we multiplied all of these by negative 2. And then after getting the value of negative 2y or negative 2x squared, we subtracted 1 from every single point. So if we are graphing, which ones are we going to graph? When you guys are graphing, you're not going to use the x squared and the negative 2y anymore, because these are your x values, and since we have a newer column for y, then pretty much we can ignore these portions and just graph negative 2, negative 9, negative 1, negative 3, and so on. So now let's describe the transformation. Again, I'm going to describe this in two ways, and the first one is by just describing the effect of negative 1 on the function negative 2x squared. So if I were to describe the transformation, I could say the graph of g of x is a vertical translation 1 unit down of the graph of, now I have to be specific with my reference graph, since I only describe the effect of negative 1, then I have to include this g of x equals negative 2x squared in my transformation description. However, if you want to describe the transformation based on the parent graph, then you could say the graph of g of x is, so first there's a negative sign here in front of 2, so negative means we're reflecting it, so is a reflection across the x-axis. Next is the 2, which was multiplied to x squared, so since 2 is bigger than 1, then we say it's a vertical stretch. So vertical stretch by a factor of 2. And lastly, we subtracted 1 for the value of the constant c. So we say vertical translation 1 unit down of the graph of let me say the original function is f of x is equal to x to the second power. So let me copy this x to the second power here. Let me copy that, then delete this one. Okay, so I just want to emphasize that your description may vary depending on what reference graph you're going to use. If you want to focus on the vertical translation only, then you have to use negative 2x squared as your reference graph. But if you want to describe all the possible scenarios, like the effects of the negative, or the constant multiplied and the negative subtracted, then you have to use the parent function as your reference. Okay, so now your vertex will be 0, -1. Is it a minimum or a maximum? Since it was reflected, it's now facing downward. So if the parabola is facing downward, then the vertex is the maximum. The axis of symmetry is given by x is equal to 0. The domain is all real numbers. The range is, since it's now going down, it's going to be less than, it's going to be less than, or equal to, the y value of the vertex is -1. Now, it is increasing when x is, less than no, let me copy this less than symbol here. Okay, so less than, but don't use the y value, instead use the x value, so 0. And then let me copy this again over here. So I'm going to change the less than to greater than or equal to 0. Alright, so that's the same graphic organizer that we saw previously, but we're focusing on the transformation caused by adding or subtracting a constant c to the original function. Okay, so I hope that helps you in graphing. In the next task, you guys will have your turn to use a similar graphic organizer and graph the functions that I indicated.